Guys, welcome to another episode of Cuda Education. Today I just wanted to bring up the topic of glTF. So basically, those are assets that are 3D assets that can be used independently of Vulkan, but also inside of Vulkan. So there is a glTF viewer, a web-based viewer, where you could drop the assets, drag the files for the assets into the glTF viewer, and you could view the assets independently. But then you could also put these assets in your scene. Fair use for educational purposes only. This is a picture of a helmet, right? And as you can see, that it is very this is very realistic, right? So you could see even on the inside of the helmet, and all these plugs and all this stuff, right? So pretty cool stuff. What does it say here? Flying helmet, etc., etc., etc. So you want to be able to put these assets into your ray tracing application to do whatever you want to do with it. But just so this is a thing inside of Vulkan. You could use it in Vulkan. Now, one thing we'll have to investigate is notice the number of shaders associated with this example, right? So the two main things that I want to tackle with this one is why there's so many shaders. That's number one. And then this idea of for proper transparency, this sample does frame accumulation. I've tried to turn off frame accumulation, but it doesn't really show much of a difference inside the application, even when you try and turn it off, right? So I want to investigate that, and I want to investigate why there are so many shaders. Also, something that I want to highlight is that apparently Slang, remember I did a video talking about the importance of shaders, right? So, Slang is making a concerted effort to innovate and to make a lot of new features accessible to Vulkan and computer graphics programmers through their shader and shader language and all that stuff. But one thing I just want to highlight here quickly is that notice that this for this example, there are not too many, shaders. Everything is combined within sort of one or two files, right? And we could see that even with let's see, ray tracing basic, we have 3 files for GLSL, but then for Slang we just have 1 file, right? So there's a certain level of conciseness and efficiency. Now, I don't know if generally programmers prefer to just have less files to deal with, like everything is just in 1 file, but you see, like even here, it's just 1 file for Slang, and it's 3 files for GLSL, right? So just as a little side note. But yeah, this glTF business, I do want to spend some time investigating. For now, my focus is on GLSL. Why are there so many shaders? What are these shaders doing? And sort of this frame accumulation idea. I've tried to turn it off, and it just, it doesn't really show anything much different. I do also want to highlight that you could investigate these assets independently of Vulkan on the web. So here you can see the assets, the flight helmet asset inside of a web viewer. And if you go to that website up there, you will be able to see, you'll be able to basically drop in the files for the flight helmet and get this. Fair use for educational purposes only. I'm using this asset, so I just wanted to make sure you guys understand that. But you could see here, you could also change the background, do a lot of things. See the mesh, skeleton, the grid for, I guess, world space and all that, right? Um, you know, right? Do background color. You could change the lighting, right? So it's pretty cool stuff, and this is all just in on the website, right? Uh, you have to drop the entire folder, so it's not just it's not just a file. It's a glTF folder inside of the assets folder for GitHub and all of that. Why is it so dark? You understand? So guys, computer graphics, as you can see, even with this, it's the right color. So you can see, guys, computer graphics, and you have to understand, like with this stuff, we even have metrics down here. Now this is outside of Vulkan, right? This is just a glTF viewer. It's maybe using some other technologies and stuff to see this stuff, but people spend a lot of money to create these models, and they spend a lot of money to buy these models, right? Depending on your application, what it is you're trying to do. So for you guys that are artistically inclined, this is definitely a look, right? You definitely have, an opportunity to sort of, use your creativity to sort of be relevant. So, lighting, right? And of course, we have performance metrics and all of that stuff, right? So, I just wanted to highlight this thing. I will, make some effort into figuring out what all of these shaders are about and what it's doing. Here is the basic code. Fair use for educational purposes. But yeah, we're almost done with all of the ray tracing examples. So I'm pretty excited about that. I think I still have to do callable again, but the only real one I think is ray tracing textures that I have to finish. And then we're done with the ray tracing examples. But there you have it, guys. Thank you for watching. Have a great day. If you want to, definitely check out tutorial number 1 and tutorial number 13 to be able to run these examples. Now, I assume a ray tracing capable GPU, and I assume a Windows machine, and obviously, a Vulkan capable GPU, right? If you have a Vulkan capable GPU and a Windows machine, you could run all the other examples. But if you want to be able to run the ray tracing stuff, you need to have a ray tracing capable GPU. For NVIDIA, it's RTX and above. For the others, it is a non-issue. For the others, I don't know what GPU you need. All right, guys, have a great day.